Good afternoon, dear students. Today we are going to discuss about gel filtration chromatography. Gel filtration chromatography is also known as gel permeation chromatography or molecular sieve or molecular exclusion chromatography. And this technique of separation is dependent upon molecular size. That means gel filtration chromatography brings about the separation of components of a mixture depending upon their molecular size. There are many advantages of this technique over the others. What are the advantages? The advantages are gentleness of the technique, which permits the separation of even sensitive or liable molecules. Almost 100% of solute recovery is there. The method has excellent reproducibility and it requires a comparatively shorter time. In addition to that, relatively inexpensive instruments are required to carry out gel permeation chromatography. And it's a very powerful separation procedure so that samples which differ only by 25% in their molecular dimensions can be totally separated in a single gel bed. Okay, so these are the advantages of the technique over the others. Now, what is the principle on which the technique is based? The gel permeation chromatography is based on a very simple principle. A column is filled with gel beads or porous glass granules. This column of gel beads or glass granules is allowed to attain equilibrium with the solvent that is suitable for separation of the molecule. If the mixture of molecules of different size, that means the sample, is loaded on this equilibrated column, the larger molecule pass through the interstitial spaces of the gel beads and they move out very quickly. Okay, this is because the pores of the gel have very small diameter and large molecules cannot enter inside the pores of the gel. That is why large molecules do not face any obstruction and therefore they move down the column with little resistance and they come out very fast. Whereas smaller molecules which have smaller diameter can enter inside the pores of the gels and hence are effectively removed from the stream of the eluting solvent. They do not enter directly into the stream of the eluting solvent. Rather, small molecules enter inside the pores of the gel. These molecules hence are retarded. Okay, the degree of retardation of the molecule is proportional to the time it spends inside the gel pores, which is of course a function of the molecular size of the molecule and the pore diameter. Now you can see in this diagram, this is a column. We can see a column filled with gel beads. Okay, the gel beads are porous. You can see here a cross section. Porous. It is having pores. Okay. Now, if the molecules present in the sample are very large and they cannot enter inside the pores of each gel bead, then they will come out along with the eluting solvent, which you can see by a solid line. Okay, the large molecules. This is the black solid line is the path of large molecules which come out uninterrupted. Okay. Right. The dotted line is showing the path of small molecules. The small molecules, what is happening here? The small molecules enter inside the gel beads. Okay. The inside the gel, porous gel. And that is why their movement is retarded because they interact with the gel rather than coming out directly along with the eluting solvent. From this cross section, we can see that molecules that are too large, as you can see this molecule, this is too large and it cannot enter inside the gel bead pores. Okay, that is why it will come out very fast along with the eluting solvent. Whereas these molecules which are very small, which I am circling here, the molecules which are small enter inside the pores and hence they do not come out very fast. Rather, they take their time. Okay, rather you can say the time required for their separation depends upon the time they spend inside the gel. Similarly, you can see in this diagram, larger molecules which are shown by dark blue color come out very fast. You can see in this diagram, okay, the dark green colored large molecules, right? The whole sample is loaded on the surface of the gel column, right? And when you proceed, when you allow the eluting solvent to flow through the column, the larger molecules uninterrupted. See the last one. The larger molecules that are uninterrupted come out of the gel very fast, right? And the smaller molecules, which are shown by red color, being smaller in size, enter inside the gel, and hence their movement is retarded and they come out after a little span of time. Okay. Now, what are the different types of gels that are used for carrying out gel filtration chromatography? Now, the gel that is used, the gel filtration medium that is used should have certain characteristics. What are those? The gel material should be chemically inert. It should not react. It should preferably contain very small number of ionic groups. Okay, gel material should provide us a wide choice of pore size as well as particle size. And a given gel, all the particles of the given gel should be uniform and should have same pore size. The gel matrix that we are using should have mechanical rigidity. It should not be fragile. It should not break easily. Now, there is no such single material available which can fulfill all the criterias. However, there are 5 different types of gel media which are used for carrying out gel filtration chromatography. What are those 5 types of gels? Number 1, dextran. Number 2, agarose. Number 3, polyacrylamide gel. Number 4, styra gel. Okay, and number 5, porous glass beads. That we will discuss in the next presentation.